Good afternoon. I am Mr. Ish. Thank you for joining me for this video. Understanding redox reactions or oxidation reduction reactions. A general overview of redox reactions will be provided in this particular video. These are not difficult to understand, but they're tricky because these type of reactions disguise themselves in the normal, everyday, ordinary reactions. There are many reactions out there which some students fail to understand that they are indeed redox reactions, but they're just hiding as such. Redox reactions are those reactions in which you have a change in the oxidation state of the entities involved and you have a transfer of electrons. Consider this reaction we've seen recently in another video. Zinc plus HCl to give you ZnCl2 plus H2 gas. This is a reaction of a metal and an acid to give a salt and a gas, but many students will generally classify this as a single replacement reaction in which a single entity replaces another entity. The hydrogen is replaced by zinc, and that's about it. But it is indeed a redox reaction, an oxidation reduction reaction. Why is that to be the case? Because if you were to look at the oxidation states of the entities, you will see oxidation reduction occurring. Zinc here has an oxidation state of 0. Hydrogen over here has oxidation state of 1. Chlorine has a -1. Here chlorine each has a -1. In general, you have a -1, -1, 2 chlorines. Here you have a +2. Here you have a 0. Now look at the entities which are involved. You have zinc, you have hydrogen, and you have chlorine. And look at how the oxidation state changes. Zinc goes from a 0 to a +2. Chlorine goes from a -1 to a -1. There's no change. Hydrogen goes from a +1 to a 0. Now which of these species demonstrates a change in its oxidation state? It's this and this. In which case do you see oxidation and in which case do you see reduction? Think about this. Oxidation is the loss of electrons. Where the oxidation state has changed such that you have a loss of electrons, reduction is a gain of electrons. Now in which of these species are you seeing a loss of electrons? When you look at this reaction of zinc, you can write it in this way. Zinc, in terms of zinc, you can view it as this. Zinc went from Zn with an oxidation state of 0 to a +2 with 2 electrons coming out because it balances it out. Hydrogen went in this way, H plus hydrogen ion plus electron to give you H2, but we have to balance this, and when we balance it we end up seeing that. You see now which of these species underwent oxidation, meaning it lost electrons? Zinc. Which of these species underwent reduction, meaning it gained electrons? Hydrogen. Hydrogen gained electrons, 2 electrons. Zinc lost electrons, 2 of those. The species which undergoes oxidation now acts as a reducing agent. The species which underwent reduction acts as an oxidizing agent. So we know zinc here was oxidized because it lost electrons. We know hydrogen here was reduced because it gained electrons, and you're figuring out all of this by change of the oxidation states. But zinc then is also a reducing agent, and I'm using here a abbreviation, reducing agent. Any species which is oxidized acts as a reducing agent. Hydrogen here was reduced, therefore in combination with this chlorine HCl acid, it was your oxidizing agent. Acids are generally oxidizing agents because they are reduced, and in the process they end up oxidizing something else. Here the zinc got oxidized, but you see how a single replacement reaction here was indeed a redox reaction. Zinc had a change in oxidation state, hydrogen had a change in oxidation state. Zinc was oxidized, hydrogen was reduced, but zinc served as a reducing agent. Remember again, oxidation is the loss of electrons, reduction is a gain of electrons. Let's look at one more example and we can put all of this into good perspective. Let's look at this one. Carbon plus oxygen gives you carbon dioxide. You wouldn't expect this to be a redox reaction, but it is, because there will be a transfer of electrons. Look at the oxidation states. Always start with the oxidation states. What's the oxidation state of carbon? It's 0. What's the oxidation state of oxygen? Here it's 0 because they're neutral species, but when they come together over here, you know oxygen is more electronegative, carbon is more electropositive because it behaves more as a metal. Here this behaves more as a non-metal in this compound. Here you know the oxygen is going to be -2 because there are 2 of these oxygens. They have an oxidation state of a -2, and this will have to be a +4 to neutralize it. Now you can see clearly there's a change in the oxidation states. When you're looking at the carbon, the reaction for carbon was this. Carbon went to change in oxidation in that it went from a neutral species to this. and 4 electrons were lost from the carbon because those 4 electrons were pulled by the 2 oxygens. For oxygen, the reaction is such as this. Oxygen O2 plus 4 electrons, which were pulled out of the carbon, are now being attached to these two electrons each, and you have something like this. And that's exactly what you end up seeing. And now when you're looking at this, you see carbon lost electrons, so the carbon is oxidized. You see that the oxygen here, in terms of its item here, gained electrons, so the oxygen was reduced. But whatever that was oxidized was your reducing agent. Whatever that was reduced is your oxidizing agent. Here oxygen is your oxidizing agent and it's reduced. Here carbon is your reducing agent, and in the process it's oxidized, and now you're beginning to see it. You could combine all of this and you should end up with that, with the items cancelling out. You'll have C plus O2, you'll have C4 plus, you'll have plus O2 4 minus, which these together can combine to give you CO2, and that right there would be a confirmation that everything over here is good. It would be a neutral species. Plus 4 and 4 minus would combine and you'll have that neutral species, neutral compound as you see over there. And that right there should bring us to the end of this particular video, where we were just trying to understand and get a generalized perspective of redox reactions. Thank you for watching. Have a good day.